Microstrip line feed, as you can see in this figure, it is nothing but a line feed only, or you can say a more in a specific way. If I'll mention, then it is quarter wave feed. Okay, so quarter wave feed, basically this I have designed. This is designed by me only. Okay, so this is also a contacting method. As you can see, the patch is directly connected. One more thing I would like to say for the line feed, in case of patch antenna, we can say that line feed is nothing but a extended part of a patch. Okay, and that too, it is modeled in such a mathematical manner that it will provide a impedance matching with the port. With the port, it will provide the impedance matching of the 50 ohm. Okay, and it is very simplest amongst all, in order to design, in order to fabricate, in order to test, in order to connect a connector as well, that is SMA, SMP, anything. And it is very easy, and that too, in this line feed only, we are having so much of variation, like as you can see, tapered feeding, series feeding, and then meandering is there for planar antenna, phase array. It is very easier, okay, to design, very easier to design, first of all. Okay, now second is coaxial feed. Again, as you can see in this right figure, if it is properly visible, I do not know whether it is properly visible or not. So as you can see, it is also one kind of a contacting method only. The inner conductor pin is directly connected to the patch. As you can see, very thin cylindrical line is going to patch, and this outer pin is connected to the ground. Okay, so these types of feeding, as I have said, inner conductor will be there, which is called as pin, which is connected to the radiator, and outer conductor will be connected to the ground plane. Benefits are many, easy to match also, easy to look at. Mainly L by 6 to L by 4 we have to maintain. L is length of the patch. Low spurious radiation will be there. But the thing is, designing it is not a complicated task. However, fabricating is the crucial part, because if at a desired location, if the inner conductor of the coaxial connector is not connected to the patch after fabrication of the antenna, then it will give undesired result totally, and bandwidth gain, anything, it can deteriorate very badly. And fixing that uh, fixing that coaxial connector at that point is very crucial task, and it has to be done a very important, having a full care only. Okay. Then further we'll say, we will discuss aperture coupled field. Aperture coupled field, it is very difficult. It is toughest for all also, and usually high dielectric constant is used for all lower substrate and thick. Generally, as you can see, first of all, I'll consider this as well. The bottom in which it is written, aperture coupled field is toughest of all. Okay, and high dielectric constant is used for lower substrate and thick, as well as low constant dielectric thick. First of all, thick substrate has to be made, and low dielectric constant for the topmost substrate. This is nothing but ground plane only, and this is only the slot. Okay, and this is further nothing but a main uh, substrate which is having a feeding structure. Okay, so the main advantage of this kind of feed is that optimization, independent optimization. Suppose if I have to change any ground slot and all, so I have to alter these parameter only, either slot length or slot width, nothing else. I do not need to bother about ground dimension, bottommost substrate dimension or the topmost or patch, nothing I have to worry about. Similarly, other, if I have to vary suppose feed network, then that can also be done irrespective of disturbing other parts of that. Okay, spurious radiation will be more actually moderate. I have written though that because of the open structure in between the gap. And regarding the fabrication, fabrication is also very tough. Why? Because you have to align, not perfectly I'll say, because perfectly nothing it will be there exist, but you have to align it very well, and that to maintaining the height whatever you have used while designing. In between means height nothing but gap between the parts, okay, such as ground or substrate or bottoms most substrate, like that you have to maintain a very good ratio. Designing, in terms of designing, it is not a big task, however, because of this because of the simulation, it can give you, you can find out appropriate results, but while it comes to fabrication and testing, it is very difficult. So it is recommended to use the shortening post in order to align these layers. Generally what will happen if you are using some metal also sometimes people will use in order to align it, but if it is not properly aligned, means mathematically it has to be done so that any other field it is not going coupling with that metallic post. If it is done, then again your radiation pattern will deteriorate because it is also metal, suppose a screw or something, so that can also be change the pattern. Why? Because it is also one kind of a metal and it can also radiate, like that it can be done, or not even radiate, but it can absorb the energy, it can absorb the change the field pattern, that can also be done. Okay, and then the last one will be the proximity coupled. Proximity coupled, it will be having a largest bandwidth. Now, why largest bandwidth? Because we are using two substrate. Now, substrate thickness has been more, so substrate thickness is more. So, in case of this, fringing field is more. Fringing field is more means it can travel very large distance to the layer, bottom layer. Okay, because it is going from conductor to dielectric only. Okay. Okay, now it is also easy to model to some extent, not each. Spurious radiation is very low. Why? Because there is no gap, and the feed, whatever the feed network, as you can see in this image, it is confined between the two layers of the dielectric, and these two dielectrics are not having any gap in between them. Okay. However, the fabrication is more difficult. Again, you have to align it properly, and it is not necessary that you have to use the same dielectric material for both the substrate layer, or the same thickness has to be there. That is also no rule, no thumb rule is there for that. It depends upon you, just for having a better bandwidth, some gain, better directivity, because in case if you are using for a higher frequency, then the wavelengths are shorter and shorter, so it can easily get confined. So that way, that time, low dielectric constant is preferred. Okay. Now regarding the impedance, if I'll conclude, then already this feeding network, mainly I'll say that feed width defines your impedance. Okay. So length of the feeding stub and width to line ratio of the patch determines the impedance matching. If you will decrease the impedance, if you will decrease the width, impedance will increase. Generally, inverse relation will exist between the feed width and the impedance. Okay. So by this, I will end up the third module as well. From the next module, we will start our microstrip patch antenna, and after that, we will start the circular microstrip patch antenna, that is CMPA. What are the formulas are there that we will going to discuss, and we will see some more factors based on it. Okay, thank you so much. I hope you have enjoyed this session also. Whatever, if you're having any other query, let me know. Definitely I will look into it, and even though if it is the scores will end up, you can contact me anytime. Okay, thank you so much.